Hello. In today's video, we're going to start talking about complex numbers. This is the first of 5 videos that I have planned on complex numbers, and this first video will cover the definition of complex numbers. So in this video series, learning the terminology is very key to being able to do the math. So complex numbers have a real component and an imaginary component. The real component could be a number could be a number like 7. And the imaginary component could be something like minus 2i. The imaginary component always contains I. And so this gives an example of this complex number, 7 minus 2i. Complex numbers can also be abstract, in which case standard form specifies a as the real number and bi as the imaginary component. So a second way to represent complex numbers, and probably the best definition, is a plus bi. The key to working with complex numbers is that complex numbers work just like any other binomials. Binomials being two-term expressions, because we have these two terms, the real number and the imaginary number, except that the imaginary component has a built-in value. So the built-in value is I. What is I? I is defined as the square root of -1. Now, there is no number n such that n times n equals -1. If there was such a number n such that n times n equaled -1, then n would be the square root of -1. This number, I'm using n to represent a real number. Consider, if n is positive, we have positive n times positive n, which is going to give a positive number. And if n is negative, we've got negative n times negative n, which again gives us a positive number. So there is no number that equals the square root of -1. And so I has been defined to mean the square root of -1. Now, a second key that we are going to need to deal with negative numbers is this one. The fact that the square root of a times b equals the square root of a times the square root of b. You can play around with this and find out why it's true, or you can just accept it as an axiom. But this is how we're going to isolate the square root of -1 by itself in future videos. And that is also a key to working with complex numbers. So we have two keys. First, they work just like other binomials. And secondly, we have to remember that when you can factor the term under a square root, the square root of that term is equal to the square root of the factors multiplied by each other.